In this video, as I said earlier, I'm majorly going to discuss about electrolysis of molten sodium chloride, which is an organic compound. So, molten sodium chloride, the key thing that you need to know is it is an ionic compound. Sorry for that. It is an ionic compound. And as I said previously, ionic compounds conduct electricity in molten stroke aqueous state. Now, you really need to understand what molten and aqueous state is. Molten is when a solid is subjected to a higher degree of heat until it melts to semi-solid. Aqueous state can also be defined as dissolved state. So it simply means that I'm taking my beaker and in that beaker I must have water and I'm adding salt, which is simply sodium chloride into it. So it's like at the end of the day I will be having salt solution. So those are two different types of ionic compounds. One can either be in solution and another one can either be in molten state. And in this video I'm going to discuss about electrolysis of molten sodium chloride. So when dealing with molten sodium chloride, these are the things that I need to know. What is my electrolyte? How am I going to arrange my electrodes into that electrolytic tank? And at the end of the day, will electric current flow? And I can only justify that molten sodium chloride can be able to conduct electricity if the switch is closed and the bulb lights. If the bulb fails to light, it means that electric current have not flown through that given system in the electrolytic tank. Now, these are the first key things that, or the structure of what I'm going to have at the end of the day. Now, in my electrolytic tank, I'm going to have a sketch of it. In my electrolytic tank, I'm going to have something like this. Don't worry about the sketch. It's just to enable you understand what we are dealing with. In my tank, I also need my electrodes. I'll have my electrodes. I said can either be platinum wire or carbon electrodes, majorly graphite. And into that, I also need my the solution upon which electricity is going to flow. Not really solution, but molten form of sodium chloride. Also need to know that I'm supposed to be having a switch, then source of electricity, which I said can either be a battery. I need a bulb, which will justify if really electric current has flown through that system. So after having my sketch, the next key things that I really need to know is that when analyzing my substance or the molten sodium chloride, I need to know when now in molten state I'm having ions that were forming sodium chloride compound. So in the solution or in the molten form, I'm going to have sodium ions, chloride ions, sodium ions, chloride ions, sodium, chloride ions, sodium ions, chloride ions, sodium ions in that molten form, because it is that that will enable me understand that what I'm dealing with have ions, and these ions can be attracted differently to different electrodes based on their charges. So I really need to know that I'm dealing with molten sodium chloride, and when dealing with molten sodium chloride, I have my ions in the electrolytic tank. Now, the next thing that I need to know is which electrode is which. And we can really know that when we look at this stage here, where we have the source or the battery. In physics, you are taught that this longer bar denotes that is the positive terminal, and the shorter bar denotes that it is the negative terminal. So this one, the positive terminal is always called the anode. The negative terminal is always called the cathode. So in each and every stage, you really need to know what will be the effect. Where the switch is closed, what will be the effect, or what will happen in this system when the switch is closed. So, as I always teach my students, there are simple terms that you need to know whenever you're handling electrolysis. And I always say that this is how we always start our statement, that when electric current flows into the system, these are the things that will happen. At different or each electrode. So you really need to know, because we've started the analysis already. So you really need to know what is happening at each and every electrode. So the first thing, at the anode stroke positive, you can even call it positive electrode. as a student, you really need to know what will happen at the anode or positive electrode. Now, when electric current flows into the system, we know very well that anode is positively charged, and therefore, based on the rule of electrostatics, we know that like charges will always repel and unlike charges will always attract. So that principle in physics enables us to know what will happen at the anode. So when electric current flows into the system, chloride ions will be attracted to the anode. They'll be attracted to the anode. And if they're attracted to the anode, before what really happened, I want you to understand something here, which is very key. I want you to understand something here. When I was having sodium chloride as an ionic compound, what really happened was sodium gave its electron to chlorine based on the principle that in sodium it is having electronic configuration of 2 to 8 to 1, and the chlorine has electronic configuration of 2 to 8 to 7, because it is number 17 in the periodic table. For me to form this compound, sodium will lose one of its electrons, and this one, or chlorine, will gain the donated electron so that they can be stable. The key thing here is to attain stability. So this one will be having a 2 to 8 stability. This one will be having 2 to 8 to 8 stability. So you really need to know that sodium gave its electron, one of its electrons, to chlorine to make it stable. So when we subject this system to electrolysis, chlorine needs to return back the electron that it took from sodium, because sodium needs that electron back for us to form a pure form of sodium metal. That one is very necessary, that each and every student needs to understand whenever you are handling electrolysis. So that was just by the way to enable you understand what we are dealing with here. So that's what's going to happen. So when the chloride ions are attracted to the anode, what will happen to the chloride ions? The chloride ions will donate back or lose the electrons they got from sodium when we are forming the sodium chloride compound. So what is the reaction? Now the reaction at the anode will be chloride ion needs to form chlorine by donating an electron. That is the reaction that is happening. But you really need to know that based on the analysis of the periodic table, I told you that chlorine is a diatomic molecule. It exists as a molecule, and the molecule is diatomic. So the real reaction that is happening will be, now two chloride ions will be forming chlorine gas and donating 2 electrons. Now this is the reaction that is happening at the anode, meaning electrons have been donated and we formed chlorine gas. Next thing I want us to know, reaction at the cathode. Really need to know reaction at the cathode or the negative terminal. Remember, at the cathode is negatively charged, and when it is negatively charged, the only ion now in solution that has opposite charge to the cathode electrode is sodium. So the key thing you really need to know is, when electric current flows in the system, sodium ions will be attracted to the cathode electrode. And what will happen? Sodium ion will gain the electrons donated by chloride, chloride ions. So if that's what is happening, what will be the reaction? Now I'm going to have sodium ion accepting electron to give me sodium atom. But what really happened? What really happened was 2 electrons were donated by 2 chloride ions, giving us a chlorine gas. So we have to give a justification of that. So we are going to say 2 electrons must be accepted. So we need 2 sodium ions to give us 2 moles of sodium metal. So this is a solid. This is always in aqueous or molten state, and this is the reaction that is happening. Now, most of the time, most examination bodies will ask you certain things to justify or give the observations that will be seen during this electrolysis. So you really need to know, the justifications of observations that will be made. So those justifications will really tell the examiner that you've really understood what you're dealing with. Now, the next thing that I'm going to handle is the observations that will be made during electrolysis of molten sodium chloride. I call them observations that will be made. Now, at the anode, we have specific observations. What moved at the anode was chloride ions. They formed chlorine gas by giving us 2 electrons. So what will be observed is color of chlorine gas. And chemists know that chlorine gas is a greenish yellow gas. We call it greenish yellow gas. So you won't be penalized if you say it is a yellow gas or a green gas. It's just to understand that sometimes, as far as observations are concerned, A student can mistake a yellow gas to be green or a green gas to be yellow because they are almost closer as far as color is concerned to each other. So you can choose any. You can say you've observed a green gas or a yellow gas at the anode. But how do we always give a justification for a gas? Chlorine is partially soluble, almost all not soluble in most solutions. Now we are at liberty to say that we will see bubbles. So what am I going to say? Bubbles of a greenish yellow gas is observed at the anode. Now this is going to be your observation at the anode. The next stage is the observation at the cathode. So I really need to justify what moved at the cathode was sodium ions. They gained 2 electrons. They formed sodium solid. And remember, I'm dealing with carbon electrode or platinum electrode. So what do I expect? After sodium accepting electron and forming sodium metal, I'm going to have a lump of, well, let me not use that, I want to use a ball of sodium metal below the cathode electrode in the electrolytic tank. But what is the color? So we know very well that sodium is a silvery white metal. So I'll give a justification that at the cathode, a silvery white metal is observed deposited below the cathode electrode. This will be the observation made at the cathode because it is a lump, is a solid lump that will be deposited below the cathode electrode, and that solid is silvery white based on the color of sodium, metal. So that is the observation that will be made at the cathode. So generally, that's a simple explanation of electrolysis of molten sodium chloride. In my next video, I'll handle electrolysis of not really molten, electrolysis of sodium solution or aqueous solution of sodium chloride. Thank you, and let us meet in the next video.